Hello everyone, my name's JoshJrumJrastic and welcome to another suggestion video. Today's video is by Comic Relief, I believe, or Cosmic Relief, I think. And it's called The Organism. It's 19 minutes long. Make sure you have your water with you. Water's very important. Anyways, guys, as always, if you enjoy this kind of content, consider leaving a like on the video. It'd be very much appreciated. And if you're new here, hi, I'm Josh, and this is what I do. I react to videos, and sometimes I play video games. So if you enjoy that kind of content, consider subscribing and sharing my videos with your friends so that I may grow and we can all watch and play some awesome videos and video games together. And if you have any suggestions of any videos you'd like me to watch, go down in the comments below, leave me the link or title to the video, and I'll get back to you as soon as I possibly can. Anyways, on with the video.
Right, in this video, I'm going to talk about life. One of the most elusive and most overrated phenomenons that is so arrogant that it's the only thing in the universe to make and watch videos about itself. But not just that, I'm also going to talk about the largest living thing in the universe that we know of today. A giant photosynthetic sheet with incredible repair mechanisms and one of the most complicated reproductive cycles of all time. It's ancient and ever-changing, as well as potentially one of the smartest entities alive in the universe today. As well as going over some new topics, this video is basically also going to revisit some ideas that I mentioned in some of my other videos, like Drown My Laptop and Breaking Walnuts with My Mind. So, bits of it are a recap, but I hope that it's also expanding on old points which I've made.
Okay.
Right, let's do this. Before I can talk about the largest thing alive, I first want to talk about the smallest form of life, how it started and how the rules that governed it govern us and everything else alive on the Earth today. So, what are the rules of life? Life needs to be able to sexually and or asexually reproduce, with the offspring being susceptible to occasional irregularities referred to as mutations, whereby their components change while still allowing the life form to reproduce effectively, if not better. Ultimately, if a mutation doesn't benefit the host, then the host is less likely to have offspring than something else with a beneficial mutation, or something that doesn't have a mutation at all, which means that those with bad mutations ultimately end up dying out, and that's just evolution. Most of the people watching this video have probably heard a similar sort of description of evolution before, and while I think the description works, I don't think that it does a good job of showing how simple life really is. For starters, it almost suggests that life has some sort of intention or goal that it has to follow. Basically, life doesn't have a definition for its own existence, it's just a good way of categorizing a reaction that results in something replicating. And not replicating perfectly, which then results in the ability to accidentally get better through more chemical reactions. On the early Earth, life most likely consisted of tiny microscopic strings referred to as RNA or ribonucleic acid. They were composed of 4 weak connectable pieces, each connected to their own respective strong spine-like piece that could support any one of the 4 weaker pieces and could form strong connections with other spine-like pieces. 3 of the connectable non-spine-like pieces in RNA are the same as in DNA today, being cytosine, guanine, and adenine, with a different component called uracil taking up the function of thymine in the RNA. RNA as a structure is still present in modern day cells and is currently used to carry information stored in the DNA out of the nucleus of eukaryotic cells to be translated into enzymes. In prokaryotes, they hold the same function except the nucleus isn't there, with the DNA instead being in a large loop structure in the center of the cell. Okay, so what I've just said was basically a lot of jargon for the sake of jargon, so to summarize it a bit further, RNA is basically just a load of weak Lego bricks glued to a stronger support Lego brick. Adenine can only connect to uracil in this instance, and guanine can only connect to cytosine. And all of the components are glued to a different brick that can form strong connections with bricks of the same type as itself. This system alone arguably fits the definition of life, because these components float through cold water and through random collisions with each other they can form long strings connected by the spine. They can then replicate by forming weak bonds with their opposing components to create their direct opposite RNA string, which is then separated when the water heats up again. They are also capable of mutation. In instances where 2 or more large structures meet, some sections could connect perfectly but still leave other mismatched connections that tag along with the duplicated structure and continue on in the replication. I think that when life is explained like this, it removes the mysticism to an extent. It doesn't seem nearly as interesting or magical when you realise that it's just a load of Lego being spun in a washing machine. Keep in mind that I have oversimplified bits of this, but that's basically the gist of it. This explanation of early life has still got a few questions tied to it, such as how the spines of the RNA were able to bond to each other without specialised enzymes present, and some scientists have theorised the existence of a form of life that may have existed even before RNA. I'm not going to go into any more detail about all of the proposed stuff before RNA because basically, regardless of whether or not it existed or if there was another factor at the time, we know that RNA was the end result. One strange result of the rules of RNA is that on occasion the RNA strings would bond with bits of themselves. These bonds transform the RNA into more complicated shapes that were able to interact randomly with components in the water around them, and force them to separate or bond with each other, accidentally creating early simple enzymes and more RNA bases, which help them to reproduce much more effectively. The largest remaining issue after this point would have been the fact that the efficiency of the reproduction was completely reliant on the state of the water surrounding the RNA, and the fact that the RNA had a large space to roam, making reproduction through collision much less frequent than it otherwise could have been. Luckily, a solution to this lack of collision could also be found in the primordial soup of early Earth. In the water at the time, there were other components able to interact with RNA. Two of these components were amino acids as well as fatty acids that also floated aimlessly in the water alongside the RNA. In the water of the early Earth, fatty acids began to bond with surrounding amino acids as well as RNA bases to form a sheet of connected fatty acid molecules. One end of a fatty acid molecule is a tail-like structure that repels water, and the other end is a head-like structure that's attracted to water. And so these sheets lined up against each other so that the tails were facing each other and the heads were in direct contact with the water. Because water could still come into contact with the tails from the side, the sheet structures assembled themselves into bubbles, some of which happened to contain RNA and amino acids on their interiors due to them being integral to the formation of the bubbles and thus present in the area. The smaller interior inside of the bubbles would have allowed the RNA molecules to replicate through collisions much more effectively, creating the first early cells. And as these collisions occurred more frequently, evolution inside of the fat bubbles would have occurred at a much faster rate, speeding up the diversity of enzymes created by RNA from amino acids. The fatty acid walls were also semi-permeable, allowing the early cell to absorb more usable materials as it moved throughout the water. At some point within these cells, the presence of a new molecule called thymine would have led to the creation of DNA, with RNA taking on the role of messenger for the information stored in the DNA. DNA would become more protected in the cell over time, as the thymine molecule is more expensive to build but is less prone to photochemical mutation. Once unzipped by an enzyme, DNA can bond temporarily with RNA, connecting its thymine bonds with the adenine in the RNA and its adenine bonds with the uracil in the RNA. The RNA can then float freely until it can be intercepted by a specialized enzyme with the role of creating proteins or other enzymes out of the information stored within the RNA. This is ultimately a simplified version of the current method, as it's become more refined and thus more complex over time. And this was basically the beginning of complex cells. Not an act of precision or intention, but just stuff bumping into other stuff. It's been said that if you were to put a sufficiently large number of monkeys at typewriters and have them randomly bash the keys to their heart's content, that by chance one of the typewriters could in theory produce the entirety of the works of Shakespeare. And I have seen this idea demonstrated in no greater way than with the emergence of life from a puddle of nothing. I mean, forget the works of Shakespeare, this random chain of events actually created Shakespeare. On top of that, it's also created the works of Shakespeare, monkeys, and typewriters, as well as the idea of monkeys on typewriters creating the works of Shakespeare. The chain of events that I've described thus far led to the creation of prokaryotic cells, which are present pretty much everywhere on the Earth today. Humans and other complex organisms ranging from grass to blue whales aren't composed of this cell type, however, and are instead composed of a cell type called a eukaryote. Eukaryotic cells are distinguished from their prokaryotic counterparts by the fact that they contain other cells. The mitochondria, for instance, present in every eukaryotic cell, has its own DNA separate from the DNA in the nucleus of the cell. The mitochondrial DNA codes for the production of other mitochondria, and the cell in which they multiply can't create the mitochondria on its own. This essentially means that mitochondria could be compared to an infection, as at some point they would have entered a larger prokaryotic cell and began absorbing the resources inside. In yet another stroke of random luck, mitochondria was able to form a symbiotic relationship with its larger host, producing a substance known as ATP, or adenosine triphosphate, which is a molecule that contains a large amount of energy useful to the larger cell.
Powerhouse.
ATP also requires oxygen in its synthesis, and this energy generation is why we intake as much oxygen as we do today. Mitochondrial DNA can also be used to trace back your family along the female lineage, as we inherit our mitochondria from our mother's egg cell and not from sperm. The introduction of ATP into the larger cells may have been what directly led to the existence of multicellular organisms, as it gave the cells a huge amount of energy capable of supporting more complicated interactions. There were, of course, other specializations that took place in eukaryotes, such as the formation of a nucleus which helped to further protect the DNA and is encased in another smaller protective cell membrane. Other eukaryotic cells absorb different prokaryotic cells in addition to the prokaryotic mitochondria, one of which is present in plants and is known as chloroplast. Chloroplast produces chlorophyll, which allows the cell to generate useful energy from light and carbon dioxide. At night, most plants switch back to mitochondrial energy generation and begin to generate energy from oxygen rather than from carbon dioxide. This is why people tell you not to keep plants in your room at night, as they may cause oxygen starvation and result in your death, which is, yeah. There are, of course, other examples of cells that absorb different cells with different functions, and your cells also contain more than just mitochondria, but for the sake of time, I'm not going to go over them all. At this point in the video, it should have become apparent that life is exponential. Life is pretty much just a glorified chemical reaction with emergent properties that make it seem to stand out from everything else. We're made of organs, made of cells, those cells contain cells, and sets of cells contain machines made by strings, and those strings aren't really complicated but are directly responsible for the production of everything above them.
Well.
The further you go up, the weirder it gets, with complexity that to the eye would seem crafted by some great creator. I say to the eye, but even the eye itself is a result of this random process, designed to intake light and convert it into usable information inside of a computer made of naught but dead matter. And somehow, though none of these strings know of their existence, and none of the neurons in your brain hold their own identity, they can all work together to understand their own existence and to form a consciousness greater than themselves, so that they can sit down and look at fast flashing lights representing pictures that give the illusion of movement, and hear sound conducted through machinery that can be comprehended and converted into meaning. And here we sit, atop the complexity ladder, staring down at those below us with nothing above us. Or so we think. Have you ever looked at a flock of birds or at a beehive, or an ant's nest? The way they move is indicative of some larger governing consciousness, but they are all in fact their own separate moving components. In the same way that cells work together to form an ant, ants work together to form a nest, and in the same way that the cells do not know they're part of a larger consciousness, neither do the ants. The formation of these groups have been dubbed superorganisms, where members of the same species work together to generate something larger than themselves. This, like every other aspect of life, is entirely accidental, and developed as a way for the individuals of a group to better defend themselves. If you're in a group, you're less likely to die, because there are more people who can get killed before you. If there's a lion chasing you, you don't need to be faster than the lion, you just need to be faster than the slowest person in the group. The safety in numbers idea is actually what likely led to cells forming multicellular organisms in the first place, and this in my mind leads to there being a bit of confusion over what a superorganism really is. Put simply, I would view a superorganism as just a really complicated organism, with members of the colony taking on the roles of cells in the colony that is your body. This again ties back into the whole idea of life being some sort of repeating exponential reaction, and really this rate of growing complexity was inevitable from the start. In some ant colonies, there are specialised ants that take on specific functions in the nest. Ants born to act as soldiers, or farmers, or even doors in some instances. These ants are even willing to lay down their own lives in order to protect ants comparable to important organs, such as the queen, who takes on the role of ant production and who is thus an integral part of the system. And though these animals are all represented as each a life of their own, they work together to form something greater, exchanging information through chemical, physical, and sound-related interactions with each other and the environment around them. And ants wouldn't be where they are today without the help of other life forms. Some ant colonies invite aphids into their homes in order to farm honeydew off of their backs. Leafcutter ants grow fungus by feeding it the leaves that they cut off of trees. Humans kept pet dogs in order to protect themselves from anything that could attack them, and some tarantulas keep little frogs inside of their homes in order to protect their eggs. Foxes occasionally go hunting with badgers, and some species of lizards grow algae inside of their cells to give them photosynthetic abilities. Rabbits arguably don't benefit from being hunted by foxes, but without being hunted by foxes, their populations would grow like a cancer, eventually consuming all of the vegetation on their local land and potentially leading to extinction. And when all of these complicated interactions are summarized and put into one bracket, they're called an ecosystem. And in my mind, the ecosystem is a hyperorganism. The plant life on the planet generates energy from the sun. This energy is consumed by complex animals that take on different functions in the ecosystem. Animals aid in the dispersal of seeds in order to grow more plants, with birds being capable of transporting them over incredibly large distances. Predatorial animals are adapted to lower the number of herbivorous animals in order to stop them from consuming all of the plant life, thereby becoming cancerous and thus harmful to the ecosystem. And every form of life on the planet is built with a death clock in order to prevent them from re-adding DNA back into the system, thereby reproducing too frequently and becoming yet again harmful to the ecosystem. As in every stage of life below it, a hyperorganism is faster at evolving and adapting than a superorganism, and a superorganism can adapt and evolve faster than an organism, that can do it faster than an organ, than a cell, than DNA, than RNA. This means that its repair mechanism is incredible, being able to survive direct collisions from asteroids by quickly specializing its components to retake the place of organisms that were killed in the blast. For instance, the mammalian organisms quickly resume the position that was left open by the death of the dinosaurs. This complex organism is also incredibly intelligent, with the collective brain matter of all life on the planet. As humans, we are also part of the hyperorganism. Just as RNA creates enzymes, humans create all manner of other things, such as cars and cities and roads and kettles and farms and factories and laboratories, and thus humans are in charge of a large portion of the problem solving within the system. So, reproduction. I'll first talk about asexual reproduction and then go on to talk about sexual reproduction of the ecosystem on the Earth. In order to reproduce, the ecosystem would need to be able to create another ecosystem, and this could arguably be achieved with the use of rockets. I've always had a problem with the idea of the natural world and the unnatural world. The unnatural world is commonly defined as things built by humans, but I just don't think that works. I mean, think about it. We are part of the natural world. We're the direct result of it. Every single chemical that led to our creation has then led to the creation of everything that we have built, and thus a car is as inevitable as a cell. And a rocket is as inevitable as a sperm or a spore from a mushroom. So, life on Earth developed. It became more complex. The complexity continued to grow. Eventually, intelligent life was created. Not supreme intelligence, but enough to build things. And now, the hyper-complex ecosystem of the Earth is trying to reproduce. By spreading to planets like Mars using rockets as extremely complicated sperm or spores, it could eventually construct an offspring. But asexual reproduction is not the ultimate way to achieve the fastest rate of evolution. The honour in this regard is held by sexual reproduction. And so, humans, the ever-useful builders for the ecosystem, created institutions such as SETI, in order for the ecosystem to go out on a date with another hyperorganism. By colonising planets as more than one hyperorganism, sexual reproduction is achieved, because there are brand new ecosystem interactions that result in a unique ecosystem. Sort of like how the Galapagos is just a bunch of ecosystems merged together to create something new. And let's be honest, we can see from the Galapagos what such a collision of ecosystems can create. I mean, it's what inspired Charles Darwin to write his theory of evolution. So, what was the point of this video? It could be that humans are part of something greater. It could be that life is simple yet incredible. Or it could be that life is a strange, complex, and ever-expanding phenomenon that we just so happen to be a part of. But if there's one thing that you should take away from this video, it's that the works of William Shakespeare were created by a puddle of Lego bricks and string and just flippin' fat. So, yeah. Good night.
Well, I'm glad I've been told that. All right. Well, I'm sorry I didn't talk a whole lot, but I mean, what was I supposed to say to, I guess, his theory? I don't know. I don't know. Anyways, guys, as always, stay strong, everyone. Stay safe. Wear your seatbelt, wear your helmet, wear your mask. Don't put the flashlight behind you. Don't look at the haunted mirrors. And as always, have a nice day.